Good morning. So today we're going to take a look at the solutions for the practice problems of section 8.1. So that's the first section of your systems of equations module, and we're going to take a look today at graphing systems of equations, both on a grid, such as the one behind me, as well as using your graphing calculator. If there's time, we'll also take a look at the second set of practice problems which have to do with figuring out how many solutions a system of equations might have. So we'll get started. If you have a grid, remember that a system of equations is simply any group of two or more equations that have a point of intersection. And we refer to this point of intersection as the solution. Now, most of the systems that we look at in this chapter will have only one solution or one point of intersection, but as we'll see in the next set of practice problems, sometimes a system has no solution, and sometimes a system will have an infinite number of solutions. But the great majority of the ones we look at will kind of look like that. They'll have one point of intersection and therefore one solution. So if we take a look at this system of equations, you'll see that the first equation is remembered in what we refer to as general form. AX, BY, and C equal to 0. Remember, this one, the second equation, is in what we call slope point form. Now, each of them has a particular way of graphing that's a little bit easier, although you can graph them a number of different ways. Okay? So for the first one, the one that's in general form, the easiest way to graph it is to find 2 points, and specifically the 2 points that we're after are the x and y intercepts. Okay? Now you'll remember from chapter 7 that we can find the x-intercept simply by using x equals negative c over a. And we can find the y-intercept as negative c over b. Okay? So, remembering that each of these coefficients in our general form equation has a particular letter associated with it. The one attached to x is your a, to y is your b, and the constant term, the one that has no variable, is c. Okay? So, to find the x-intercept, just hold on a second, let me put my y-axis and my x-axis. Okay, so our value for c in this equation is negative 4. So that becomes negative 4 over, our value for a is 2. That gives us negative 2, or simply 2. So our x-intercept is right here at 2 and 0. To find the y-intercept, we do the same thing, except it's negative c over b. So negative, our value for c, again, is negative 4. Our value for b, remember, if there's no number, the assumption is that it's 1. So that gives us negative 4 over 1, or simply positive 4. So that, whoops, that's 5, that's 4. Okay, so our y-intercept is here, our x-intercept is here for our first equation, and we can simply get a ruler, join the points, and that gives us our first equation. We'll call this one number 1. For equation number 2, it's actually even maybe a little bit easier because Everything is right there. You just have to know where to find it. So for equation number 2, we know what the slope is. Remember, it's right here. y2 minus y1 equals slope times x2 minus x1. So our slope is 1 over 3. And then remember, these two numbers in slope point form give us the coordinates of a point. The x coordinate being 1, the y coordinate being 2. Remember, the signs always change when you write the coordinates. Okay? So, for our equation 2, we know that it passes through the point 1 across and 2 up, right here. And it has a slope of 1 over 3. That means to get to a second point, you have to go up 1 and across 3 to the right. Remember, these are both positive, so 1, 2, 3. That gives us our second point. And then, again, using our ruler, we just join the points. There's equation 2. So, here's our system of equations. It's been graphed, and so we can tell that the solution, even though they didn't ask us, the solution for this system of equations is the coordinates of the point where the two lines cross, which in this case is at 1 across and 2 up. So there's the solution right there. Okay? We will continue on. Explain what the intersection point of the lines represents. Just let me get rid of this. Except for this, because that's what it represents. The intersection point represents the solution or the point they share. Okay? The point that is the same for both equations. Whoa. Now, although these look kind of odd, they're just in slope-intercept form. Okay? Remember, the y is isolated, everything else is on the other side. So we could really kind of write this first equation as y equals 1x plus 0. Okay? When you don't have a constant term, all that means is your y-intercept is at 0. So let's just quickly again. There's our y, there's our x. So for equation number 1, we know the y-intercept is at 0. So there's the coordinates of 1 point. And we know that our slope is 1 over 1. So that means from our point that's known, we go up 1 and we go right 1. Remember, they're both positive, so that's up and right. And that brings us to our second point. Whoa, that was easy. And then we join the points. And let's just make... You have to be fairly careful when you're joining the points so that you can get them to intersect in the right place. For this one is y equals, and again, we'll just get rid of this. So this is equation 2. For equation 2, we could write this as y equals 0x, because you see there is no x value, minus 2. And again, in slope-intercept form, that constant term is your y-intercept. So for our second equation, the y-intercept is at -2. And the slope is 0. Now what does that mean? A slope of 0, remember, is is a horizontal line. Okay? So, we have a horizontal line, which means every point on this line is going to have a y-coordinate equal to -2. Okay? So, again, the place where those points the place where those lines intersect, that point right there is our solution. And in this particular case, that's a solution at -2 and -2. That's the point that the two lines share. Now, I'm not going to do this one because this one is just like the first one we did, where you have one equation in general form, another equation in slope point form. So you simply find the x and y intercepts for here, plot them and join them up. For this one in slope point form, it's easier to just take the slope and take the coordinates of the point. In this case, the point will be at 1 and 2. And you graph that one, extend them, and solve. This one, pretty much the same. The only difference being that you're using P's and Q's. Okay? Maybe we'll do this one because it looks a little weird and it can be confusing. I'm just going to arbitrarily say let P be our x and Q be our y. Okay? And then I'm going to rearrange both of them into y equals mx plus b. So our equation 1 rearranged to y equals mx plus b will become q equals -p plus 6, right? I just subtract p from both sides. This one will become q equals p plus 2. Again, I've just isolated q by subtracting p from both sides and then multiplying through by -1 to get rid of that negative sign. Now I have two equations in slope-intercept form. And our x and our y. For this one, we have a y-intercept of 6. So that's right here. And we have a slope of -1. So I'll just write that over here. -1/1. So that means to get from this point to a second point, you have to go down 1 and right 1. There's our second point. And by joining up the points, we end up with a line that looks like this. For this equation, our y-intercept is at 2. And for this one, our slope is +1/1. Okay? So for our second equation, that's what our slope looks like. That means to get from our known point, we have to go up 1 and right 1. So up 1 and right 1 takes us to here. Get Mr. Ruler. Join up the points. And looky here, they intersect right here. That gives us a solution at 2 across and 1, 2, 3, 4 up. There's our solution. Okay, 2 and 4. Okay, so again, remember, the solution is the place where the lines intersect. And once you graph them, that becomes fairly apparent. Okay? Okay, verifying equations. So remember, when you are verifying equations, what you're trying to do is substitute your proposed solution into both equations and check to see if the left side equals the right side. Okay? So that's what our friend Megan did, and let's just go through this because it's good practice. Okay? So you've got a left side and you've got a right side for your equation, and we'll do it for the first one, y equals 6x minus 20. Okay, so y equals, sorry, let's just do it this way, y equals 6x minus 20, just to explain what's happening here. So then what Megan did was she said, well, my y coordinate of the solution is 0, so I'm going to substitute 0 every place I see y. And my proposed x coordinate is -3, so over here, I'm going to substitute -3 for x, and then I'm going to simplify. Well, there's no simplifying necessary here, it's still 0. This becomes -18 minus 20, or -38. Now, in this case, the left side doesn't equal the right side, so there must have been a mistake made here. Okay? This is not the solution because the left side doesn't equal the right side. So, it says, she wrote the following and concluded -30 was not the solution. Well, she was right. She then showed her work to Faith, who said it was incomplete because Megan didn't check both equations. Now, when you're verifying, you should always check both equations. Okay? However, if the first equation doesn't work, then you know it's not a solution. If, on the other hand, the first equation does work and you get the left side equaling the right side, you have to check the second one. Okay? Sometimes one equation will work and the other one won't. So, if you get the first one to work, you have to check the second. However, if the first one doesn't work, then you immediately know it's not a solution and you don't really have to check the second one. You already know it doesn't work. Okay, so explain how this discussion could be resolved. You could check the second equation as well if you really wanted to. Toby drew the following graph while trying to determine the solution to a linear system of equations. So you see this graph that Toby got, okay? And it says, explain why it's difficult to use Toby's graph to determine a solution. Since the slopes are very close it's hard to see where the lines actually intersect, right? There's a whole bunch of overlap here just because the lines are so close to being parallel, right? They have nearly the same slopes. So it's hard to see the solution, okay? Explain why it's difficult. That's why it's difficult, okay? Because the slopes are so close together. Suggest an improvement to the graph that will make determining the solution easier. Well, if you were to change the scale, then it would make these lines much more apparent. It would make it much more apparent that they're different, okay? So if you were to change the scale, so for instance, maybe if you made the scale, since we're only interested in this particular portion, right, which is where the lines cross, if you made your scale only go from, say, -9 to -18, and you made this scale go from -8 to -4, that would stretch things out a whole bunch more. So the short answer would be change the scale to highlight the point of intersection. By doing that, it would accentuate the slopes and it would make it easier to see where they actually cross. Okay? Another way you could do it is use a graphing calculator. Because remember, a graphing calculator has that really neat intersection function where you can actually pinpoint the intersection. Okay, so I think we've probably got time to move on to the practice problems, part 2, and this is where we talk about the number of solutions to a system of equations. Okay, so describe a strategy to determine the number of solutions. Before we do that, let's just very quickly go over the 3 different kind of situations that you'll encounter. Okay, so situation 1 is where you have one solution, and that's going to look like this, where you have one line here, here's your solution, the point where the 2 lines cross. Okay? And if you have one solution, what can you say about the slopes of these 2 lines? Slopes are different. So, if you look at 2 equations and they're in a form that makes checking the slope easy, like slope point form or slope intercept form, then if the slopes are different, you know there will only be one solution, there will only be one point where they intersect. Okay? So that's one solution. The second group is groups where there are no solutions. Okay? And a system of equations will have no solutions if the lines never cross. Now, when do the lines never cross? The lines never cross when slopes are equal. In other words, when you have parallel lines, but also when the slopes have different y-intercepts. Okay? You'll notice that there's the y-intercept for our first line, there's the y-intercept for our second line. So, again, this is where that slope-intercept form for a linear equation is useful, and the reason it's useful is because simply by looking, you can see the 2 things that you need to check. You can see the slope, that's the m part in y equals mx plus b, and you can see the y-intercepts, the b parts, okay? And so very simply, by comparing the 2 equations, let's say one of them is y equals 3x plus 4, and the other one is y equals 3x minus 2. You can see the slopes are the same. That means they have the same steepness and direction, but the y-intercepts are different. That means they cross the y-axis at a different place. In this case, they will never intersect, right? They're parallel lines. And therefore, there will be no solution. There will be no point where they intersect. Now, The third group is a group where you have an infinite number of solutions. So, they don't just intersect at one point, they intersect at all points, okay? And the only way that that's possible is if you have what are referred to as coincident lines. So in other words, if you have one line like this, your second line, and I'm just going to draw a squiggly line to show that we do have two lines here, your second line is exactly the same. And that only happens if you have slopes that are equal and you have the same y-intercept. So that would be when your equations, rearranged into y equals mx plus b, end up being exactly the same. Okay? So if you have two equations that are exactly the same, this shouldn't be a surprise. You're going to end up with two lines that look exactly the same. Well, they should. They have the same equation. Okay? So, one solution, if you have different slopes. Solution number two, excuse me, is where you have no solutions. That's when you have parallel lines, different y-intercepts. And then this last one, an infinite number of solutions, when you have same slope, same y-intercept. Okay? So three different groups. So describe a strategy that can be used to determine if you have a system of linear equations. Step one, put them in slope intercept form. And remember, that's just y equals mx plus b. Step two, compare slopes and y-intercepts. Okay? So those are your steps. So Austin. It says Austin found that both 1317 and 2461 are solutions to a system of linear equations. How are the two lines related? Explain. So in other words, what they're asking is, do you have that first group with one solution, the second group with no solutions, or the third group with an infinite number of solutions? Well, if Austin's right, and we're going to assume he's right, there are two solutions. So obviously 2 is bigger than 1. So it's not the first group with just one solution that would look like this, okay, where you have that one point of intersection. So it's not that one. And it's not the group where you have no solutions, where you have two parallel lines, because he's saying there are two. So it's not the second group where you have no solutions. Process of elimination tells you if it's not the first group with one and it's not the second group with none, must be the third group. It has an infinite number of solutions as the only other alternatives are 1 or 0 solutions. And since it has 2, it can't be in one of these groups. So it must be in that group with an infinite number of solutions. Okay? So again, just a little kind of logic and reasoning. So use technology. So in other words, remember, whenever they say use technology, what they're really saying is use your graphing calculator. Okay? So we're going to do that quickly. It's a good review. I'm just going to write these equations down because we're going to go to the graphing calculator in just a second. So just let me put this grid on, and we have y equals 22x minus 9.5, and y equals 2.5x plus 4.1. So there's our equations, and we are going to do some graphing. Okay, so here's our graphing calculator. You may recall, if you watched my last video, that I made a very common mistake, and that resulted in a whole bunch of confusion. So we're going to try not to do that this time. Okay, so the first thing you want to do is you want to click on, why are you not? Oh, you want to click on the y equals key, and let's try. It seems to have frozen. Oh, there we go. It looks like it's thinking. Looks like we're going to have to relaunch. So, sorry. We'll just take a second, and we'll relaunch our calculator program, and hopefully it'll work this time. There we go. Now let's see if it works. Yay. Okay, so just to review, by pressing the key in the upper left-hand corner, which says y equals, we can access a place to enter our equations. You can see there are already some equations here. Simply by placing the cursor over the equation and hitting the clear button, we can get rid of those old equations. I'll arrow down, I'll press clear. So our old equations are gone. Make sure those equations are gone. Make sure none of these is highlighted, okay? And we're ready to go. So we'll put in our first equation, which is 22x minus 9.5. So 22, remember that the variable key is that one that's right below the mode key. It has an X and a T and a couple of other symbols. When you press that key, you get your variable X. And then minus 9.5. Okay, there's our first equation. Use the cursor to move up to your second equation, y equals, and then we'll plug in our second equation, which is 2.5x plus 4.1. So 2.5, hit the variable key, which is x. Oh, that's interesting. So let's just, I almost made another mistake. So let's get rid of one of those two. So just press the delete button. So 2.5x plus 4.1. So plus 4.1. There's our two equations. Now we press in the upper right-hand corner the graph button. And when we press that, there's one equation. And come on, you can do it. There's our other equation. Okay, and you can see that our two equations cross right about there. Now, in the standard window, each one of these little ticks counts as 1. So we can tell that our intersection point is at roughly, our x value is probably about 0.75. Our y value is at about 1, 2, 3, 4, 5. It's about 6. Okay. However, to get a much more accurate idea, we simply, to get a much more accurate idea, what we do is we simply take the second button, which is the blue button in the upper left-hand corner, and the trace button, which is up here on the top row right beside graph. And if we press second trace, that gives us a bunch of possible calculations. We want to calculate the intersection, so we want option 5. So if you press 5, it takes you back to the graph, and it asks you 3 questions, which you will answer yes to by pressing the Enter key. So, first question, am I on the first curve? Pressing Enter is how you say yes. Then it will go to the second line, and it'll say, okay, am I on the second curve? Pressing Enter again is how you say yes. And then finally it says, do you want me to guess? Hitting Enter a third time, it guesses, and look, it goes right to the intersection, and better yet, it gives you your x and y coordinates, which you can see, we were fairly close, okay? Our x and y coordinates, and I think it asked for them to the nearest tenth, would be 0.7, right? Rounded to the nearest tenth, and 5.8. Which is pretty close to what we kind of estimated by looking. Okay? So, back to the lesson. Okay, so now we can get an approximate solution. Our intersection, our first line has a y-intercept of negative 9.5. We're not going to get there. But you saw the graph on the graphing calculator. Here's one more. Let's just see what we have, because we're running short of time. So okay, what we're going to do is we will graph this one, and I think they still want us to use technology, so we will. Okay, so for C is a little trickier simply because we have to put these in slope-intercept form before we can use our graphing calculator, okay? So, our first one, all we need to do is subtract 6x from both sides, and that will give us y equals negative 6x plus 12. So that was pretty easy. Okay, so that's our equation number 1. Our equation number 2 takes a little bit more work. We have to subtract 5x from both sides. That will give us 8y equals negative 5x minus 100. And then we have to divide through by 8. Now, because we're entering these into a graphing calculator, we don't necessarily have to, and I would say don't convert these fractions into decimals. So you go 8 divided by 8 is 1y. This you can leave as negative 5 over 8x. This one we can simplify by dividing the top and the bottom by 4, and we get minus 25 over 2. Okay? So that's our second equation. Y equals negative 5/8x minus, y equals negative 5 over 8x minus 25 over 2. We've put our equations in slope-intercept form, and we're ready for the next step. So let's go back to our graphing calculator. And remember, we're going to press the y equals button in the upper left-hand corner, and we have to get rid of these two equations. So we press the clear button, and then we toggle down and press the clear button again. That gets rid of our equations. Plug in your equations. So equation number 1 is y equals negative 6x plus 12. Remember to use the negative key, which is in the lower right-hand corner. So negative 6, press the variable key, so 6x plus 12. There's our first equation. Cursor down to the second line and plug in your second equation. When you plug in fractions, always plug them in within brackets. Okay? So we've got two fractions to plug in here. So bracket -5 divided by 8, close the bracket. Whoops, I did it again. And then your variable x, so -5/8 x minus, and again, put your second fraction in brackets, 25 over 2, close the brackets. Oh, my goodness, this, I think it's the mouse. There we go, let's get rid of that. Okay, so -25 or -25 over 2, and then hitting the graph button in the upper right hand corner, we'll graph our lines. Okay? Now, you see we have a problem. By looking at these two lines, we can see they're probably going to intersect somewhere around here, which is basically off the chart, right? Our y-axis only goes to -10. We need it to go further in order to show us where that intersection point is, okay? So we have to change the settings that you see at the very top, right beside y equals, on your calculator. It says window. What that does is that sets the maximum and minimum values for your x-axis and your y-axis. Well, remember we said we want our y-axis to go further down into the negative. So we're interested in this y minimum. So we're going to cursor down to the y minimum, and instead of -10, we're going to say set it at -25. So what does that mean? That means that when I press graph again, my y-axis is going to go down further. It's going to go down to -25, and look at what happens when I press graph. Okay, first of all, notice my y-axis is now longer. It goes down further, and that allows, just like magic, that allows us to see our intersection point. And then, to find that intersection point, remember we're going to press the second key in the upper left-hand corner, and we're going to press the trace key in the upper right-hand corner, and we want to find the intersection, so we're going to press number 5, and it's going to ask us those 3 questions again. It's going to say, first curve, enter, second curve, enter. Do you want me to guess? Again, a third time, enter, and look, it goes right to the intersection point, and it gives you the coordinates, which, rounded to the nearest tenth, give us an x value of 4.6 and a y value of -15.3. Okay? Do we have any questions? I guess it doesn't matter because I can't hear you. We'll go back to the lessons. Now, you could very quickly, and we'll do this very quickly because I have a help session in about 5 minutes. We could use our equations in the y equals mx plus b form to very quickly come up with a quick sketch of our lines. So this line has a y-intercept of 12. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And it has a slope of -6/1, which means to get to my second point, I have to go down 6. 1, 2, 3, 4, 5, 6, and across 1, there's my second point. And that gives me my first line. For my second line, it has a y-intercept of negative 25 over 2, which is negative 12.5. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.5. This is going to look really ugly. And a slope of negative 5 over 8. I'm going to put the negative sign down here, and you'll see why in a second. Because to get to our second point, we have to go now up 5 and left 8. So that means we're going to go up 1, 2, 3, 4, 5, and across 8. 1, 2, 3, 4, 5, 6, 7, 8. There's our second point. And by joining the lines, oh, this is so ugly. Forgive me. And extending this line, we get way down here somewhere. But if you look, it's at about 4.6 across and negative 15 down. So there's our intersection point. Okay? I hope this helped. I'll be continuing to post videos for 8.2, 8.3, 8.4. Okay? Good luck with it. Please remember to attend the help sessions if you feel you need help. See you later.